Good morning, good evening, good day, greetings and salutations. And might I also add in just a little bit of a welcome and how you're doing to the Safe Room featuring security side quests. I take a dramatic pause and also say this again. The Safe Room featuring security side quests. I have to say it for the people on the backside of the internet. And we have a great show today. My name is Tristan Watty, and I am joined by the mysterious, the Maven, the Maverick, the Russ. How you doing today, Russ?
Thank you. I'm doing great. It's been a good day. I'm surprisingly active today for a Monday, so I think that that second coffee really hit, so we're good. We're looking good.
Yeah.
I'm also super excited about this episode.
Yeah, and I would say I'm still waiting for my third coffee to hit, so we'll see how that plays out. So yeah, great Mondays. Happy Monday. But for you first-time joiners, so Tristan Watty, I am a senior delivery consultant of the security variety that helps customers accelerate their journey to the cloud in a secure manner from the professional services division. And joining today with Russ. Russ, where are you coming in from again?
I'm from the customer incident response team, so hopefully you never meet me.
Yes, exactly. And we always like to play like we don't know each other, even though this is episode 12, because it adds a little mysterious. It's how we keep it in that phase of happy beginnings, right? When you first get to like camp or something like that, and you're like, "Oh, will you be my friend?"
We're just trying to keep it day one,
Yeah. See,
keep it day one.
See, that's a good place to be. And also a good place to be is wherever you are and wherever you're joining in from. So feel free to let us know, hey, where are you from? We like to see where everybody is because some people on the East Coast, some on the West Coast, some are in Asia and some are in Europe, somewhere. And thank you if you're listening past your normal working times. And it's funny because we used to do a show on a Friday, then some people joining Saturday. I'm like, you're spending Saturdays?
Right.
Yeah, it's always fun stuff. And Georgia, also a great place. And I think we also have to also throw in a second question. And
always.
We always. And that question you've been waiting for is, what's your favorite beverage, hot and cold? See, help you out a little bit today.
Yeah. So, okay, I've got some maybe a little bit weird answers. So for hot, me personally, although I like coffee and drink it pretty much every day, I'm a hot chocolate type of guy. Just for me, it makes me think of winter with some, little hot. Little hot chocolate, a little bit of whipped cream on top, a little bit of marshmallow. I mean, you can do so many things. Hot chocolate. Cold, I'll have to give it to either water, or I'm also have been really into those like Propel packets. I don't know. That's just a thing that I've gotten into and have been obsessed with. So water / Propel.
So it's funny because I think we're aligned. We see each other eye to eye because hot cocoa is on my list. Top. It's up there. I think it's undefeated just for the reason of what you said. Wintertime is overpowered, right? Because you can have a little bit of cinnamon, a little bit of marshmallows, a little bit of whatever, and you put it in there, and it's just like chef's like kiss or whatever the case may be. But for a cold beverage, I have to go back to the childhood and say grenadine and Sprite with Shirley Temples, right? You just put it together. It's just up there. If you haven't tried one, you should.
Yep.
So
it made me feel so fancy as a child.
Yeah,
you get the fancy little.
We
were doing mocktails way before it was cool.
Yeah, exactly. Right, and I think that also sets up for what we're going to be talking about. But before we get there, before we segue over to today's episode topic, I think we need to have a poll, right? I think that's a good starting place for today. It's a nice poll.
Yep.
So the last of keys is today's episode title. So what we'll start off with is around that theme. And if you get kind of the references, 10 points to you. what? Feel free to put in the chat 1, 2, 3, or 4 when it comes to describing your organization's quantum security preparedness. What are you? You're a runner, stalker, clicker, bloater? Feel free. Put it in the chat and it will pop us. I was going to say pop up for us. There's a lot of P's in there. Just but Russ, where do you
5 times
stand?
fast.
Yeah.
So I would say that I'm a bit of a stalker, cautiously observing. I haven't dealt with any quantum cases, so I'm definitely not actively responding. But I think it's one of those things where we're kind of just keeping our eye out, looking and waiting, and trying to do our best to be proactive in this environment. So yeah, I would say I'm a stalker right now. But no judgment if you're newly aware. I think that a lot of people, are not aware of what quantum, actually is or means for your security organization. So no judgment. You can, be newly aware. That's good too.
Yeah, I would agree with that. I would say number 2 as well. Cautiously observing, because there's so many pieces. But for today's episode, I'll say I'm a runner. I'm a newly aware person who's trying to figure out what quantum is for the case study, which is this show and episode entitled. Because it's exactly what you said. There's so many pieces to it, and there's a lot of good research papers. There's a lot of good AWS blogs, things of that nature, which we'll get into. Spoilers, but I think part of this is understanding the journey. And Pete also puts in the question of, is the concern encryption maybe a thing of the past? So that's going to be an interesting question, which I think we'll pocket for right now, because when we start to go through and understand how they're bread
I
mold,
did like that one.
we'll also try to figure out how we can understand what quantum is if we're newly aware, if we're the uninitiated, untrained, and trying to figure out along the journey, just like we figured out last week when we started to talk about threat modeling, right? When we delved into that, and Russ was an expert in it and kind of explained every single piece of threat modeling, right? No recording on it whatsoever, but so
don't check for clips.
Yeah, don't check for clips. So when we went into threat modeling, the same thing is like, where do we begin? And that's always the question of the day, right? Is how do we begin understanding a topic like this, and then eventually pivot into something that's applicable to my security strategy? So I think that kind of brings us full circle into today of just what are we going to be talking about? Well, I think first is talking about some of the fundamentals of quantum security, right? Where you have quantum computing, which kind of poses a significant area of interest in the current I want to say the crypto world, but it's larger than that, right? It affects every single part of, or could potentially affect every single part of an organizational environment. Then we'll talk about some of the foundational elements that make that true, and eventually pivot into some common challenges and real world use cases and things of that nature. And I think the interesting part of this, Russ, is when we say hello to Victor, welcome back, we also start to think of there's a lot to cover, and we need, since we're just newly aware today, right? We need somebody to guide us along. I don't know about you, Russ. Do you need somebody to guide you?
Absolutely. I'm an incident responder. I deal in the realm of reality. So if we're going into theory, let's get us a sage.
Yes, let's get us a sage. Somebody to show us the path, the way forward, and delve a little bit into the theoretical. And today we welcome our sage, Avik. Welcome to the show. How's it going today?
Hey, great. Thanks for bringing me in. How are you both doing today? And how's the audience?
We're doing great, I would say, right? We're on our, second and third cups of coffee. So today's going by just great. So for the people who may not be aware of your sagedom, Avik, where are you coming from in the AWS world?
Yeah, I'm a senior solution architect in global services security. So in the same sister organization as Russ is.
Yeah. So that means you have all the knowledge.
Coach
We'll
says.
say that. We won't check. We won't check, right?
As long as you don't ask me the math.
Yeah, exactly. So
I'm not gonna check your math, so you're good.
yeah. So fun math on Mondays. But there's one important question we have to ask you before we get started, and that's what's your favorite beverage, hot and cold?
Oh. So hot. Yeah, hot would be tea, right? So hot would be some kind of tea in the morning. And cold. Yeah, cold, I'm fond of like freshly squeezed fruit juices. Like if it is a cold orange juice or watermelon juice, like, that refreshes me.
That sounds good right about now, actually.
Yeah.
The way the weather has been heated up, I could go for like a nice watermelon squeezed on ice,
Yeah.
Yeah. See, it just sets up the mood for today, right? Because we're thinking about the future. In this case, we're thinking about our future lunch, but we're also talking about future in cryptology. So I think one way to start off and kind of lead us in is asking the question to you, Avik, is in our quantum scenario, right? If we are in that survival realm of how do I move my environment forward when it comes to security, post quantum, which AWS services do you think we should scavenge first to help protect our environment and our data?
Yeah. I would say like services that deals with cryptography, encryption, right? So KMS, like AWS Certificate Manager, Secrets Manager. Yeah, those would be some of the services that would be go-to services that you should look into.
Okay. I think that's a checkbox list right there of everybody write that down now. Those are the things that you're going to have to remember. There will be a quiz that Russ will distribute at the end. But I think another place to start, Avik, is for those who are newly aware, what is post-quantum? What is quantum to start off with?
Yeah, and I would also consider myself like we are learning every day because this is such a new field. So just to level set like what quantum is, and again, not the math, like for a theoretical understanding. So as we know, like today computers are based on bits, right? 0 and 1, right? So you have permutation of combination of 0 and 1s. So quantum computers are based on what's called qubit, which is the theory that everything is not 0 and 1. There is probability of true and false. So probability can be many things. So that's the power of quantum, is that it can be many things at once. And that translates roughly into like parallel processing. Right? So that's the power of quantum computers. And yeah, obviously, as we get more powerful, there are many benefits, like some things we have heard about, like genome sequencing, right? It lets lots of computing power to do it, but with computers, it would make easier those, right?
Yeah, definitely. And I think it's funny. One analogy that often stuck with me when somebody said it about quantum is like regular computers are like playing checkers. You can make one move at a time. Pieces are either black or red. But then quantum computers like having a magical chessboard where the pieces can all be in multiple places all at once. And that kind of stuck with me. And it's exactly what you said, right? With the power of qubits and leveraging that. The impossible becomes possible, as Pete says.
Yeah, and so I think the second part of what you were trying is like, why should we worry about it? Right? It's a powerful thing. It's a good thing. It's helping us. So primarily where it's affecting in security is the asymmetric encryption, right? So again, let's take back on how does asymmetric encryption work. So basically, it works on the theory that it is easy to multiply two prime numbers and get to another number. But when you have to do the opposite, so you are given a big number and you have to break it into two primary numbers, it's difficult to do because there can be so many permutations. Right? So that is the basic theory that asymmetric encryption works on, that it is difficult to undo the multiplication and come to the original number. So when you share your public keys, right, that's the computed number, and you can take the computed number, but it's very hard to get back. So for example, like an RSA 2048 bit, for today's classical computer, it would take like trillion years to compute back the original prime factorization. So that's the difficulty that the asymmetric encryption relies on. And that's where I won't say the risk, but that's where quantum computers come in. So today's classical computer take trillion years, but powerful computer, so a quantum computer can break that in 10 seconds. So with the advent of that, we can't rely on the difficulty of a math problem. We have to find other ways to achieve the same outcome. So that's in a nutshell quantum security, its impact, and what we are, not when you say we, the industry is looking into. Right?
Yeah, and it's interesting, and you snuck in a little bit of math. I saw it. See, it's sleight of hand right there, right? So it's funny. We kind of joked at one point about exactly what you were saying. Is okay to break 2048. It would take so long, right? So picture a snail, and all you have to do to stay safe is avoid the snail touching you, right? And you could just move around, right? And it'll be fine. It'll take so long for it to get across. Say if you're in Japan and it's coming from the US, right? Oh, that'll take so long. But now imagine somebody teleporting right next to you. And that's kind of the difference in the time it takes, right? So
yeah.
I'll use that next time.
Yeah. So, just picture
the teleporting snail. Of course.
Yeah, exactly.
But that is a great visualization, though. Yeah.
Yeah. Mm-hmm. So I think going along those lines and just understanding that timetable and kind of the impact on cloud security, right? Because now organizations have built their whole target state security strategy around, hey, we'll encrypt like this. Will you leverage these services? Now we start to have to think a little bit differently. Right? And that impacts just the overall, I guess, strategy of organization, because some of them are just migrating, let's say, to the AWS cloud, for example. Mm-hmm. And it's going to say, hey, over 5 to 10 years, we're going to do this, and this is what we're going to have in place. Now they have to adjust to something that's in the future. So how long should I even consider this, right, in my plan right now? So a couple of different thoughts about it. But I think another place to touch upon is what is it is not, right? So there's a lot of things that come up with quantum. So now you try to think of what it is and what it is not, right? In that tongue twister. So what it is it not?
So that's a good question in this context, because again, this quantum, and it's mostly theory, right? So first thing we have to understand is today we don't have a practical, feasible quantum computer. Like there are quantum computers that are in research world, but there's nothing feasible today, right? So there are some, I would say, myths that are floating around, right? One is like, with the advent of quantum computers, cryptography would be broken. Everything encryption would be broken. So that is not the case. As I said, it's specifically for asymmetric encryption. where we have something that is publicly known. Right? For symmetric, the premise is that you are using one key and which needs to be secret. So it's not affecting the symmetric encryption like AES-256. Even with quantum computers, it is perfectly safe. So you can use like KMS as you are using with AES-256 in the quantum, post-quantum world also. So that's the first thing to understand, right? So that we can narrow down our scope, right? Second is, which was revealing to me also, was because the name says quantum, right? So the understanding is, okay, for this to happen, for someone to break, once we have quantum computers available and we need post-quantum algorithms, all this to happen, we need quantum computers, right? Like instead of my laptop, I need a quantum laptop to do this. So that's not right. All the post-quantum algorithms, one of the requirements is that they should run in a classical computer, right? So, because not everyone would be carrying a quantum computer in their backpack, right? So that's the second myth that is broken. The third is, I think, because of how post-quantum algorithm works, is there is the notion that once those are in effect, the algorithms would require high computing powers to work, and it would increase my cost because I wouldn't need network devices that have much larger memory and things like that. But that's not the case, right? So in the research, it has been that the PQCs, or the post-quantum compute algorithms, they are actually more faster than today's algorithms. And again, not going into the detail, the only heavy lift is during the initial handshake when it happens. But again, going back to how TLS works, is the initial handshake is the asymmetric. After that, everything is the symmetric, right? So because quantum is not affecting the symmetric, there is no change there. It's just the initial handshake that's where it requires a little bit of amount of work, but that spreads over the whole session that is in effect. So those were the three, I would say, myths or realities that need to understand, so that, again, we can focus on what we need to do, not boil the ocean.
Yeah. I think that's an important part to kind of lay out as well, is because when you start to think of something grandiose, you start to get overwhelmed. What we like to say around here is break things down to the ones and zeros, or maybe not. Is see what I did there? But it's funny. One of the things when you were talking about too, I just pictured somebody with a quantum laptop in like their local coffee shop, just just working on something. But I think it's exactly that. It's just understanding what it is and what it is not. Those simple things. When you think of the PQC, you want to think of, okay, what proactive security measures can I build in now that probably can apply later on? Because not everything is going to just poof, like you said, right? Everybody thinks everything's just going to end, like, oh, everything's exposed, right? It's like, no, my S3 buckets are not quantum leaking. Right? You just want to make sure that you're going along the path of just understanding what it is. And hey, what can we do to help us prepare? And to Pete's point is, not everybody has a security plan. And this is part of the reason why we want to establish, and why Russ always says the thing at the end when it comes to incident response plans. But I think taking to the next step is, when you think of an organization, Russ, I'll start with you, is how many months of planning would you think it would take an organization to become quantum ready?
How many do I think, or how many would it actually take?
How many do you think? Because there's no right or wrong answer right now, because it's all theory.
Yeah. So right now, I guess basically with its current state, then I mean you're already protected from quantum. But when we're talking about the possibility of quantum, you know, there is a lot that I'm going to use AWS for an example. I feel like that's obvious why. But you can use right now, you know, you can create, you know, quantum resistant keys right now in KMS, just using the, what is it, the PQ.KEM instead of the pen. So it can be very simple. You know, we have even Security Hub now has they have some quantum resistant configurations. So ooh, I got a little too excited there. But there is there's a lot that you can do right now to switch over, like creating quantum safe keys in KMS, using certificate manager and secret managers, quantum safe operations. So realistically, I don't think it would take very long at all. But I'd like to hear Avik's answer to see if I'm right or wrong.
Oh, yeah. Like, so there are a few things. One is to understand the timeline, right? As I was saying, quantum computers are not readily available today, right? Again, there is no D-Day that it would release, right? So, but again, yeah,
Exactly.
the same thing, right? So we have to understand, as per the research or the trend, it says like at least 5 to 10 years before quantum computers would be available with the computing power and the stability to break the current algorithms, asymmetric algorithms, right? So we have to understand that timeline. We have 5 to 10 years before this happens. But we also have to understand then, okay, if it is 5 to 10 years, as Tristan was giving the analogy of the snail, like, why are we talking about it today? Because of two things. One is, from history, we learn that the time takes to update all this. If you see for an enterprise that was required to update to TLS 1.2, what was the average time period? Okay.
Yeah.
So now we are talking about updating everything that is asymmetric. So the average time period is 5 to 10 years for an enterprise, right? And so if we start now, we are early in the game. So we don't have to hurry and plan accordingly. Second is, there is a attack vector that is called like record now, break later. So as I said, like asymmetric encryption is working on the concept that it's hard to break. But if I am an eavesdropper, I can go in and capture an HTTPS traffic today, right? Now I can store that, and 10 years later, when quantum computers are there, I can break it. Now, what's the risk? It depends on the data that is, right? Suppose someone is capturing my credit card, which would expire next year. I should not be afraid. Like even if they break it 10 years down the line, the card is already expired. But if they were capturing my PII 10 years down the line, fingers crossed, I will be living, breathing. And at that time, if they get my PII, I should be concerned, right? So that's a threat vector that currently is working. And that's why organizations should understand, firstly, where their asymmetric encryption is happening. Right? And secondly is what type of workload would be affected by this threat vector, right? And that's where they can prioritize. Suppose I have 10 web services that is capturing data, but out of those 3 have long-lived data requirements. So I can prioritize those 3 instead of focusing on the rest 7. So that's what a timeline perspective looks like.
Yeah. And you make a lot of good points with that, because what you see is exactly what you said is how long does it take an organization to move and upgrade their documentation, their compliance standards, right? Having the meetings to talk about what direction they're going in. All of that takes months and then years. And then we get to implementation at some point. Okay? And I think part of accelerating that piece, and we'll spoil it for a little bit later, is when you look at the AWS services, you start to think of, hey, what can I put into place now that can be maybe a toggle or just a simple update to the CloudFormation or Terraform a little bit later, to your point. So all these things we have to take into consideration, especially when you think of exactly what you're doing is I'm just going to store this information and, all right, if I know a card expires 2 to 3 years down the line, well, sometimes I know it's going to be the same numbers and the same information, just plus 3 to the expiration date. So it adds that additional attack vector to your point. So I think what we need to do in order to prepare for this is get to a point where we have an understanding of what's going on in the world. And the one way to do that is to look into our legends of the SideQuest variety. So we have our Sage today, and what we like to do here on the Safe Room featuring Security SideQuest is go on SideQuest. Spoilers in the title, but the SideQuest is essentially for you new joiners when we take a little bit of dive into a particular topic on our SideQuest board, which is of the physical variety. And with that SideQuest board, what we do is we go over a customer scenario, you go over a persona scenario, a stakeholder scenario. Sometimes I put on the announcer voice, sometimes I can't because I don't have enough coffee. But as SideQuest legend has it, there was a security engineer at, let's say, a global financial institution managing cryptographic assets across multiple AWS environments. They're facing an increased pressure, let's say, in order to prepare for quantum threats. Because, hey, I have all this data in S3 bucket. I have my AWS environment. I'm just this lone security person out here trying to figure out how to make my way in the, I was going to say quantum realm, but comic book fans might comment in the chat. But when you start to think of this, the case scenario is the same, right? If we go with our theme of the last of keys, you need different skills, you need different understandings of what quantum is. So if we had to build out a team of quantum security, what would their superpowers be? And I pose this question first to Avik.
So, yeah, usually, again, I won't say what we have seen because, again, enterprises are working toward it, but it helps is ownership, right? Like, because it's so widespread, right? Typically, your applications are using TLS to talk to customers, or I would say external users, right? And so as you are building this, there should be some defined owners who are responsible for this program management, right? It's a multi-year initiative, so it's a program. And there should be defined owners who are taking ownership. It's not mean that they are doing everything. It's that they are the owners of this initiative, right? So those would be our primary persona, like establish the ownership. And then it's up to them that they define. Second would be, I would say, vendor management. Again, these are all quote unquote non-technical, but these are the pillars of the success. Because if you're an enterprise, you're using AWS, you have the shared responsibility, right? So you can't go in and make changes to KMS, but you need to understand when AWS is supporting post-quantum, which we are already doing, but saying a vendor X. Suppose your OS provider, right? You are most probably not building the crypto libraries yourself unless there is specific use case. So you are relying on these vendors for different aspects, and you need to understand with them that what is their timeline, like, and if I rely on them, what I am getting in turn. Like, so if I am using OS version this, is it already supported? Or what is the shared responsibility? Like vendor would give us the OS, but we need a plan to upgrade to a particular version, right? So understand the shared responsibility, the vendor management.
Yes,
Yeah.
we're going down the road of the SideQuest board of understanding. All right, first couple of items is building out that team, as you mentioned, right? That's not exactly technical, but it's just understanding the people and the processes. Like we have our vendors in our group right here, right? We have 3 of them. Then we start to go down the line. Let's see if I can make this look a little bit better. There we go. Right. So I think the other piece is the challenges to consider as well if we continue on this scenario, because managing quantum security preparation while dealing with maybe teams that use deprecated cryptographic algorithms, right? We were talking about it before. I think it's going to come up again. Inconsistent key management across the cloud environments. Different individuals deploy differently within the organization, even though there's guidelines. Sometimes people kind of go a different route, and then we'll fix it later. We have to launch now. How many times have we heard that before? And the limited visibility into the crypto dependencies themselves, because hey, what is the single pane of glass that we have to view within the organization? And I think to address some of these challenges, and correct me if I'm wrong, but I think we have to look at how we use key management within the environment. If we look at something like KMS, I think that's an important part to start out with stuff that we can do now. Just understanding how do we deploy keys, how do we manage keys, how do we rotate keys, how do we move forward on a day-to-day basis in the present before we even look at the future, because the future is tomorrow, and if we don't have today right, then tomorrow is going to also be bad. I think I heard that in a Sage's quote sometime. But what do you think about that, Avik?
Yeah, and that is the classical, I would say, a security challenge, and that our customers can do today. They don't have to wait for anything. Is inventory, right? Like, I think we have been talking about as an industry, but there is no silver bullet to it, right? There is no one tool that does inventory for everything. If you are on AWS, you have config, system manager, and resource groups, things like that help you do it. But ultimately, inventorying is an enterprise responsibility, right? Like, you have to know where asymmetric is happening, right? Then we walk backward from there to know, okay, what are the vendors and services involved? Suppose asymmetric is happening, that is front-ended by an AWS service. Then we can say, okay, the scope is AWS, then look at, okay, which service is supporting or what is their timeline. On the other hand, suppose asymmetric is happening on an on-premise server that is hosting something that is servicing my front end. Then I have to see that, okay, it is now my responsibility. What am I using for that? Which vendor I'm using for certificate management? And what are their timelines, right? And as you said, Tristan, like there are what we call SADO ITs, right? Like we never approved for this certificate, but someone is using it. It's public. It has an URL. So let's find out who is responsible for this, why they are using it. And it's also an exercise where we can think about that, okay, does it make sense to manage ourselves, or should we leverage a managed service provider or a managed service? Right? What are the pros and cons that we are getting?
Yeah. And I think that's a interesting thing, because where that often comes up is config. When you start to think of, hey, managed versus unmanaged, right? I'll just create my own custom stuff, right? So when you start to think about this in the future, how I'm going to manage my environment, how I'm going to alert on configuration changes, things of that nature, because we have to look at the whole estate, right? Because it touches everything. When you think of cryptographic resources and key management and things of that nature. So that's one piece. And I would also say, when you're looking at the strategy, I also put in Security Hub in there as well, right? Of just understanding, hey, how can I gather all these different pieces of my environment to understand that one satellite item that somebody has somewhere, is it reporting properly? Because oftentimes that may be excluded because, hey, it wasn't on the main paperwork of who's taking care of this account and things of that nature. Just maybe some guy in a shed in Alaska, right? That's all I do is manage the heating and cooling, and I just have this up and running. Right, that's why I have a certificate. It has to be secure, so I put a certificate on it. They told me to do it. Now you have another item that you have to account for. So eventually, we wrap our trail back around in some form or fashion, and you can tell there's a couple of spots where there's a loop, and that loop may be on purpose. You know why? Because there's still no right path. We're still building out the road because we're still trying to figure out what concrete to put on the floor and what things to include, because this is groundbreaking items, right? Because as Avik said, 5 to 10 years out, we got to start thinking about the different paths that our organization can take and the different side quests, because it's important, but also because it's the right thing to do when you're thinking about your long-term security strategy. So I think at this point we hit the Zach Morris timeout button, the pause game button, and we kind of jump back into our understanding of, hey, what are the next steps? I think this is an important piece to discuss because we talked about some of the basics of just understanding what quantum is and what quantum security is. But when it comes to maybe initiatives, what, Avik, great sage, what should we think about when it comes to next steps?
Yeah, so we talked about one of the stages, which is the inventory, which is so important, like for anything security. Like, so once you get a hold of inventory, then start understanding your dependencies, right? Like whether this is managed, whether I have to contact the vendor. Like, as you said, like if it is on AWS, we take the responsibility of making sure those services support post-quantum, right? So, and we already started doing it for many of the services. So you have to understand, okay, what configuration changes do I need to mandate, right? What policy procedures do I need to change to make sure that right configuration is being used? Second, I would say not second, the third thing is wherever available, start testing, right? So as you said, in AWS services, we already are supporting the niche standards in some of the services, and we are looking to support everything in next 5 years. Now, as I said, in quantum, asymmetric, and post-quantum cryptography, the algorithms, the initial load is during the handshake, right? When the client hello happens, that's where some initial load happens, right? Because we are using new algorithms. So if you have, especially on network devices, suppose because they are built in, like the memory is built in and it is expecting certain kind of load. Now, if we go above that threshold, the device may behave differently, right? And we don't know that. Now, we need to, wherever possible, test those out and see what else do I need to change, right? I may be good with my inventory, I am good with the services, but my network device cannot take that. So I have, again, those are the dependencies that are there that I need to understand. So again, roughly inventory, dependencies, and wherever possible, have some testing plans to initially test out the effect in my environment. And again, 3000 level up, a program that manages all this, right? So that we are not 6 years down the line and now scrambling to do all this thing in next 4 years.
Yeah, exactly. And I think another good place to start is kind of talks and just listening to different people's viewpoints on quantum, right? Because there's so much research that's being done and performed, and kind of to your point of, okay, theoretically, if we have this hardware from a networking standpoint, are the ports just going to shut down? Because it's passing this new level of traffic. Because you have to think, especially within hybrid environments, of, okay, I have this capability in the cloud, but I also have a local on-prem data center that I manage maybe the everything, the network infrastructure, the data, the storage, everything like that. Now, how do I get those pieces to play nicely together with this? Because there's so many factors that go into to your point. So if I were a customer, what would be something I can do today? Right? I listened, I got inspired. Where do I go to next?
Yeah, so there are two things you can do today. One is understand the industry, where it is going, what's happening. So a few things like in US, like things like NIST, National Institute of Standards and Technology, right? NIST has been, I think, started in 2016, started this process of evaluating cryptographic standards, and they have already finalized 4 standards around key encryption and signatures. So keeping abreast with this, like what is happening, what new standards are coming out. And there are other standards like ETSI and Open Quantum Safe initiatives. So understanding industry, where it is going. And the second thing is understanding, like, as I said, your vendors, like AWS, what AWS is doing, right? AWS has been in a leading forefront of this. Like, we have been contributing to all the standards that were developed. So we had authors of these standards that were Amazonians that are developing this. And secondly, we have been, as you said, putting them in our services, right? KMS now, as you said, support the post-quantum key exchange algorithms. We also have, like, internally, we use the AWS libcrypto, which is the library that all the services use. And we have been updating and supporting updated standards in those libraries. So when times come, it's easier to propagate that. So those are the two things that customers can do to keep abreast. And one very practical thing they can start doing is, if they are not already, starting to upgrade to TLS 1.3. Because TLS 1.3 would be the standard which would start supporting post-quantum, right? So if you are today updating to TLS 1.3, you are halfway there.
Yeah. And I know some customers are going to be like, I just got from 1.2. Yeah, it's interesting because time flies. Because I think when did TLS 1 become deprecated? I think 2020, around there, that time frame, something like that. But it's that same thing of looking towards the future because, we don't have to deal with that yet. And then what ends up happening is the reality starts to creep up, and then it's like, we have to get off next year. Right? What are the risks if we keep on this older version? That usually becomes the conversation. So being proactive. And Russ, I think there's one other thing that people could do today, right?
Yes, you can like and subscribe to our channels and follow our show. But I also do have another question for the audience, but we'll discuss it here. So just what's the biggest obstacle in quantum preparation? Is it budget? Is it time? Is it skills and knowledge? I would love to hear your answer, Avik.
Oh, yeah, I think it's hard because it's a combination. One's a skill and knowledge, right? I think that's the first thing, because again, it's so new, right? So to narrow down the scopes, like the things we discussed, what it is not, to understand that and narrow down your focus so that you can make use of your resources well. Like we all know, like resources, budget, everything is constrained, right? And so whatever we get, how do we make use of it? So that the best way is to focus on what really affects me and taking care of that, and then moving on to the rest of the things.
Yeah, and we definitely have some interesting comments in chat where you need to train the human firewall. Yeah, and and thank you, Pete and Darrow, for that. It's interesting because you start to think of all these different items, right? It is budget, time, and knowledge. Is a combination of all three. It's kind of like, three triangles come together. If you get that reference, 10 points to you. It's balancing all these things. But I think one area where is relatively free, I would say, is to understand, hey, how can I build up my knowledge on a particular topic? And that's what we like to also delve into in the show. And that is, hey, go on a knowledge quest. What is a knowledge quest? Well, essentially, a knowledge quest is where you can take a piece of information and help build up your expertise, help to build up your knowledge. But most importantly of all, you can build up your aura. You can build your aura. And you can also do what in a knowledge quest? You could force multiply. May the 4th is coming up, so I had to throw in a force joke. So with a knowledge quest, you can go on an adventure and choose your own path. Either if you're a level 100, level 200, or level 300. And in today's theme, if we were thinking of that post-quantum area, I do the dramatic pause to say, hey, maybe I'm just a lone outpost person trying to figure out how my organization, my environment can go to the quantum. I keep wanting to say quantum realm, but I don't know why. If you know why, you probably know why. But I think a place to start off is just understanding, hey, from a L100 level, what can I do? Well, I can start to delve into just understanding what KMS is. I think it's a nice, simple place to start, especially from an L100 level. And you figure out everything Avik tried to, embrace us with, right? Try to share some of the sage wisdom with is coming from some of the best pieces of documentation, like KMS and also Security Hub. These are common services that organizations that people are using today to understand, hey, this is how I like to secure my environment using AWS best practices and also, security reference architecture. Well architected, there's a bunch of things that you can look into that you can prep for, even TLS 1.3, as Avik was mentioning. But also the concept of least privilege. I think that's something that won't change, right? I'm just looking into the future a little bit because least privilege, least privilege, least privilege. You say it 3 times for people on the other side of the internet because that's something that you need within your organizational structure. Also, SCPs and RCPs, and we'll get into that another time. But I think another place, if you go from an outpost to kind of a stronghold with the L200, I think that's where the next set comes in of just understanding, hey, what is the migration plan? This is something from NIST. Avik, have you seen this before?
Yeah, and this is a good place. Along with, I think there is a similar from Etsy that provides migration plans for enterprises. And it's, again, it gives you a head start, right? You get a structured methodology, you get structured templates that you can start off with, right? So you understand how to go about it. Yeah, I think this post is about AWS, how AWS is planning their migration. So that it serves 2 purposes. One is information, so that you have peace of mind that we are doing what it takes to save our customers' data. And secondly, also take inspiration, right? Like some of the steps may seem familiar with your enterprise. So you can draw from this and make your migration plans.
Yeah. And I think this lays out a good fundamental blueprint for just understanding where do I start and where do I go. Following the AWS blogs and documentation, what comes out from NIST, and kind of, hey, TLS is now supported over here. What is that? I think that's the important question to ask is like, hey, it supports this. Why does it support this? Kind of delving into that a little bit, right? And talking about the post-quantum world. So I think the other piece that you want to get into after you build your stronghold is, how do I turn it into a fortress? Well, it's kind of hands-on keyboard a little bit, because what you want to do is you want to start out with the theory, and can I put this theory into, I don't know, practice? Hey, it's understanding. How can I leverage the tools that are currently at my disposal to help me build this fortress out? And this workshop is an interesting one. And Avik, I don't know if you've seen this one before.
Yeah, and it's again, what you just said, like what we have today, like we have the crypto libraries, we are supporting the SDKs with the libraries. So just getting the feel of it, like how can we use those as a end user and build my part of the shared responsibility model, so that you're getting into the practice, right? And as more and more things come, it's not a surprise to you.
Yeah, exactly that. And that's the thing, is we like no surprises, right? Unless it comes with a cake. And what we like to delve into is, hey, go on these knowledge quests. Let us know if you went into the workshop, you read a couple of bits of information, the bits and bytes. You, after your 5 a.m. run, you picked up the article and said, hey, they knew what they were talking about a little bit. But if not, that's also okay. You know why? Because what we like to do here is build upon our experience points, one piece at a time, one XP point at a time, until eventually we level up at some point in time. But we only have a couple minutes left. So what we want to leave off on is 3 things. The first item is a poll. And based on our, I hope, coherent ramblings today on quantum, is, what skill do you think, audience, is most critical to quantum security readiness? Is it the crafting, the listening, the stealth, the teamwork, right? Developing new solutions, threat intelligence, obscuring data, cross-functional collaboration? Put 1, 2, 3, or 4 in the chat, and feel free to comment. I think for me, is developing new solutions. I go with 1. I don't know, Russ, Avik, where do you go?
So I would go with 4. After listening to Avik, I think that that leadership buy-in and having, you know, your entire organization, not just your security team, thinking about this is going to be probably most crucial, in my opinion.
Yeah, and I would +1 that, like, again, coming from the experience of enterprises upgrading to TLS 1.2, it was more like a process challenge than a technical challenge. So yeah, there would be technical challenges which can be solved, but the process is a bigger one.
Yeah. And again, there is no right or wrong answer, chat. So feel free to put it in as we continue on with the last couple seconds, last precious moments of knowledge that we try to imbue upon from our perspective. But I think if we had one line to leave off, starting with you, Avik, what line would you summarize this whole episode with?
Understand what it is not, and inventory. Start inventorying. It doesn't solve only quantum, it solves many other problems.
That is a good takeaway, and that sounds like a tagline and a sequel. So I think we have to have a sequel on this topic. Mine would be keep on side questing and keep on building on experience. But Russ, what would yours be?
For this episode, I would say is you know, looking towards the future. So you know, in reference to quantum, you know, it's not a concern right now, except in an academic or theoretical sense. So just kind of keeping that in mind and not panicking, making the changes early while it's still theoretical, before, you know, it becomes an issue and you have to see me. But the one thing that you can do, the practical thing is create an incident response plan.
Yeah. And he said the thing, so that means its time is up. And thank you, Avik, for joining us today and sharing all the wisdom. I think we all leveled up just listening to you and talk about math in a, you know, I saw you sneaking in, so we're going to go with that. So until next time. Yes. Everybody, have a good day. Happy Monday. Take care. Dream quantum dreams in your quantum realm. So take
Dream of
care.
quantum sheep.
Yes. All right. Bye.